explanation for laboratory number 3. So for the demonstration of my program, first I'm just gonna compile the file and I'm gonna execute it. The input that I'm gonna put here are just those stated in the example in the activity guide. So I'm gonna input 24 and then 9, and then I'm gonna execute it again, and this time the 9 goes first and then 24, and as you can see it works fine. So that is for the demonstration of my program. Next, I will explain the code. So here is the overview of the code that I've written for this laboratory exercise. But for this explanation, I will be using PowerPoint to clearly explain some of the code that I've written. So first, here are just some preliminary usual segments in an assembly code, such as in this lines here, the segment.data are just some memory that is initialized that stores some data. This data is the messages that will be printed out later in the code. Then next, for the .bss segment are just some reserved memory space for the data that will be stored in later. The labels here correspond to the num1 and the first number, and the remainder for the first number, remainder for the second number, and the GCD value. This reserved memory space here will be used in later in the code. And then over here is just where all the instructions will be written. The ASM main will be identified as global, and it is where all the instructions will start. Now here for this line here, enter 00 and push A are just some setup routine that I followed from the author of the book. And then next, for this part, this is just going to print the message. This program calculates the GCD of 2 integers as stated in the activity guide. Then next here it will print out the prompt, and then it will read the integer that is inputted by the user. And then the next here is just the same as from the above, where it will print the prompt and then it will read the inputted number by the user. Now here, the EBX register is set to have a value of 1. This EBX register will be the main key in the while loops because it will be used as the iterated variable for each iteration of the loop. Now here within the while loop, first what I did was I located the remainders for both of the inputted numbers as they are divided by the current EBX iteration. In other words, I modulate the numbers, and if the remainder would be 0, then that means the current EBX iteration is a possible value for the GCD. Here in this part, we can see that first I cleared out the value of EDX for division, then set the value for the EAX register as the corresponding inputted number. Then I divided them and then stored the remainder in the corresponding memory label. After that, the program has to check the remainders if whether both of the remainders are zeros to ensure that they are indeed possible GCD values. The program did this by sampling and adding both of the two numbers remainder, then later checked through comparison with 0. If the remainders were indeed 0, then it would jump to the label set as GCD and store the current EBX iteration as the GCD. After that, If the current EBX iteration is not divisible to both of the numbers, it will undergo to another comparison to check for the terminating condition where the while loop has to end, where the current EBX iteration is compared if it is greater than either of the numbers. This is made possible by the JNL jump instruction. Otherwise, if the iteration is not the terminating condition, then it will just increment the EBX iteration by 1 and it will jump to the while label to perform a loop. After all of that, as mentioned earlier, when the EBX iteration is already greater than 0, then it will jump to the terminating label, the end underscore while, where the instructions here will print out some messages as stated in the activity guide. First, it prints the message, the greatest common divisor of, then print the inputted numbers, then finally it will print out the GCD value. Then the last parts are just some exit routine that is from the user of the book that I'm following.